Now we're live. Okay, so in your lab, first thing that you're going to want to do in the upper right-hand corner is name, date, and periods. Let me put my name, put your date, which is what, 8-22-25, period is 1, first period. I need to zoom in so we can see this better on the video. So zoom to 100%. Did that do anything? Zoom, 150%. There we go. Zoom, 200%. Yes. Okay, now we are rocking. Okay, skip a line, go back to your regular indentation. Then we're gonna write our title. So title, I usually tab so I can get it like aligned. Title should be underlined. So our title is density of, let's do glass marbles. Density of glass marbles. Skip a line. That's the only thing that should be underlined. What comes after title? After title is second section in a lab. Up higher. One above that. Purpose. But I appreciate all of the tries. I'm going to tab twice. Did you guys notice that I spelled density wrong? Okay. Density. So what would you say the purpose? The purpose of this lab is to what? Determine the relationship, right, between mass and volume of glass marbles to find the density. That is a pretty good purpose. Now what comes after purpose? Background. What do we usually put in background? Definitions, safety, and one other thing we usually put in background. Which we may need later in the lab. Equations. Equations. So what equation may we need first? Density. So density equals mass divided by volume. So that is one thing we might need. And then we're also going to need the accepted value. The accepted value of glass is 2.6 grams per milliliter. So those are the calculations we need to actually do the lab. We're not going to put percent error in there because percent error was not a calculation we needed to actually do the lab. Does that make sense? Percent error is just something you need to figure out data with later. Okay, that's a pretty good background section. After background would be hypothesis, which I said there's not a great hypothesis for a lot of chemistry labs. So I would say on this one is the hypothesis that will be tested is that as the volume of the marbles, I guess, increases, comma, what should happen? As the volume increases, what should happen? The mass of the marbles will increase. Period. This results in a what?
Higher density. Same positive.
Yes, direct relationship. This results in a direct relationship. That's why your line's going to look like this when you graph it. Okay, that's a great hypothesis, which we wrote after the lab, which a lot of times we kind of do. It's just like chemistry labs are not great labs for hypotheses. Are we good? Am I moving too fast? Okay. After hypothesis, what comes next? Not yet. Not yet. Variables. Matthew on fire. Let's go. Okay, variables. The independent variable is what? What did you control? What did I control in this lab? Which would be the, not the mass, you controlled the volume, right? Didn't you control the amount of substance you put in, and then the mass would have depended on that?
Yeah.
So the independent variable is volume. And then we say, how will we manipulate that? So and will be manipulated by, what did we say? How do we change that? What? Yes, by the number of marbles used. So you say what the variable is and how it's manipulated. Then we'll go to dependent variable. The dependent variable is mass, right? And will respond, because this is what's going to depend on the independent variable, right? Respond by doing what? We just talked about this in our hypothesis. Increasing as the volume increases. Does that make sense for variables? What about controls? Controlled variables. That is not spelled right. I cannot spell today. Controlled variable. I don't think temperature is going to have an effect on this lab. What's going to have an effect? What should stay the same? Yeah, that's good. The amount of water. What else? Type of marbles. We can put the temperature just for fun. The temperature remain the same.
Would the pressure be better for this?
It doesn't really matter. We'll say temperature. I would say temperature would affect density more than the other. The same graduate and balance was used. So lots of controls. The same graduate and balance was used. Okay. Now what are we finally ready for? Procedure. So skip a line. Procedure. You must write your own procedure for what you did in this lab. I don't know how many steps it'll be, but you need to write it step by step. So that'll be on your own later. Okay? What do we not use in procedure? Pronouns. We don't use I, we. Like we say, step one. You would say, pour an amount of water into a graduate, right? Record the amount. Step two, add marbles. Like, you see what I'm saying? So don't say it like in first person. It's not written in first person. So that's your procedure. It should be written so a third grader could follow it. That's usually the goal. A smart third grader. It's like my daughter. She could follow it. I mean, most third graders could probably, well, they probably wouldn't know what a graduated cylinder is, but if they did, then, well, my daughter does, but has no chance. She's going to be a science geek no matter what. So, are we good on procedure? Okay, so do that on your own. Now we're ready for materials. What materials did we use? Marbles. What size graduated cylinder? Wasn't it 100 milliliter? I think it was.
Yeah, it was.
100 milliliter graduated cylinder. Hey, Officer April. Good morning.
Good morning.
Happy Friday. How are you?
Oh my gosh, you got such a big class.
I know, small but mighty.
Holy smokes.
I know.
These are all the troublemakers, man.
I know. AP chemistry. That's what you would expect for this class.
Yeah.
What are you going to be doing this Tuesday?
I will be stopping in for Tell Me Something Good Tuesday.
Yes. Officer April comes in every Tuesday for Tell Me Something Good Tuesday now. It's great. Anytime. I won't be here fifth period. I have planning. I have nobody that period. But any other period,
So
stop
first
in.
period's a good one?
Sure. It'd be great.
All right.
We would love that.
And you've got, such a big class. I don't think we're going to get to everyone.
I know. Probably like one or two.
Maybe.
I'll share. Maybe you share. Maybe one other person can share something good.
Yeah, we don't want to hear a whole lot of good.
No. You don't want too much, especially on the first Monday of school.
No.
Yeah. So, yeah, just making sure you're coming back this year.
I will be back.
Okay.
Be back. Did you get your, oh yeah, you said they were excited.
I have these done so far.
Yes!
Officer
All right.
April's making a coloring book.
You know when like you were a kid, you thought you had all these grand ideas that you were gonna do when you were older? Well, I thought I was gonna write a book. Well, it turns out I'm not gonna write a book. I'm gonna make a coloring book. Using real pictures as like the inspiration. Oh look, you gave me lipstick. Love it.
I didn't, the girls did.
I said, she, yeah. All right. Oh, wow. And Officer Timko went goth on this one.
Yes, he did.
Woo!
It's incredible.
Wow. Man.
So there's
check
your
out
first-
my smile, though. Like,
Let me
maybe
see your
it's
smile.
Maybelline.
Yeah? Yeah, I don't know what happened to your teeth on that one, but
You know, that's fine.
yeah.
Fine. So I've been doing this with, I printed off ones that had me in it for his kids to color because they know me. So it's not literally just a book about me, I promise. It's officers all across the board. So fun. Oh, can I have these?
Yes, they were so excited when they got the letter. I'm like, guys, look at this letter. They're like, it's Officer April. Yeah. So there you go.
Perfect. All
Okay.
right, so if, chemistry doesn't work out for you, coloring books.
Coloring. I think there should be a competition between students and like teachers somehow. I'm not sure how that would work, but like pick a picture and like we should have a competition between students and teachers. We all enter in our picture and then someone picks out the winner. I don't know. Just throwing it out there.
Okay, no, I'm good with it.
Maybe the Christmas one around Christmas time with Officer Timko as Santa. I don't know.
Yeah.
Well, I don't know who that was as
It
Santa.
was Officer Timko.
But I've never seen him and Santa in the same room, so was it him or was it Santa?
Oh, you're right.
Just
You
saying.
don't want to give up the mystery, the magic.
Right, exactly.
Um,
So just throwing it out there.
well, I'll give you guys the scoop on this. I have ordered what's supposed to be a realistic 2.5-inch figurine of myself.
Whoa.
That we're gonna do like a Where's Waldo kind of thing.
That's incredible.
Didn't we used to do that with like a Lego figure?
Yeah, and then it went away.
Yeah.
So I gotta figure out, like, I gotta put it in some sort of display case so I can put an air tag in it, because
Oh, that's a good idea. Air tag's a really good idea.
who knows where it's gonna go.
Yeah.
But again, like, people can still trash it or something, but
Yeah, but
at
you
least if
could
they
you could
know
check
it-
cameras.
At least if they know there's an air tag in it, maybe
Yeah.
it won't go missing.
Put a little backpack on it and put the air tag in the backpack.
Oh, love it.
Yeah.
Now I gotta figure out, maybe there's like a Barbie backpack I could find.
Ooh, I like that.
So, but I thought that would be kind of fun, like, either do it like a Where's Waldo, like you gotta find it and take a picture with it, and then you get a prize, or should it be like a Flat Stanley thing where you get to take it somewhere and take a picture with it and then bring it back for somebody else?
What do you guys think?
Do you think it should just stay here? That's probably the safest. Probably.
What's a word for find that starts with a P? Pinpoint police or procure. I don't know. Instead of Where's Waldo, it needs to be like something police or
Do something with April.
Yeah.
what's a word
April away.
that means find that starts with A? Acquire April? Apprehend April. That's incredible. That's what it has to be.
Wow.
That's so appropriate. Okay, well, there's some
You guys
ideas.
are my marketing team.
There's some ideas.
Think about it. Let me know.
Okay.
Get back with me.
There's some ideas.
All right.
Have a great day.
You too. We'll see you guys.
Yep. Okay. Cylinder. We got that.
Yeah.
Marbles. What else? Electronic balance. Water. I think that's it. Right? Next section. Data. See attached. So what you will do is you will turn in this for your data table. For calculations, there's two options. What I prefer, what I would do is I would say calculations, See attached. Here's why. When we're getting into stoichiometry and calculating moles and mass and density, it is not great to type all that stuff out. If you want to type it, go for it. If not, I recommend just doing your calculations underneath your printed data table on the data table, okay? And sample calcs. So on this one, wherever it says calc, you have to do a calc. I don't need to see a subtraction calculation. I know that you guys know how to subtract. So calc 1, density of marbles, you need to show one 3-line method for density. Calc 2, percent error. So show me your percent error calculation. 3-line method. So put that under here or type it, it's up to you. Cool? So always have labeled like what calcs you guys need to show. Just one, not all 3. Make sense? Okay. So that is calculations. Are you guys good with making the graph, the mass versus volume graph? Okay, we might have some time at the end where I can help you with that. Okay, conclusion. This is where I want to make sure we know how to write a good conclusion. Conclusion, the first thing you do is you restate the purpose. The purpose of this lab. And then we'll say was to determine the relationship between mass and volume of glass marbles to find the density. So I've restated the purpose. Okay? The next part is this was accomplished by, in this part, this next part is your part. You're going to summarize the procedure in a sentence or two. So you guys will have to put that in there. I do not want you to repeat the whole procedure. Okay? Just give me a 1 or 2 sentence synopsis of the lab and say what we did. Cool? So you're going to summarize that. Okay. Then we're going to talk about data. So we'll say data was used to construct, right, a mass versus volume graph, which you may not have done yet. That's fine. And then you will say this, or the graph, showed a blank, you guys can figure out what that is, relationship. You should know what the answer is. If you want to fill that in now, you can. The data shows, well, we already kind of said that. Well, then you would say the data shows a direct relationship, right? Between what? So it would be between mass and volume. Okay. The density of glass marbles was found to be, you'll put your number in grams per milliliter. So whatever your number is. And then you'll say this resulted in a percent, not a 5%, error of blank. That is a good conclusion section. Cool? That's the conclusion section. Last section. Limitations. I just call it limitations, all right? Because we're going to put the improvements in there as well. If you want to write improvements, you can. Limitations. Okay. A limitation, we need 2, of this lab was what? What did you guys write down for your observations?
Crack the marbles.
What?
Just cracks the marbles.
Ooh, okay. Was the marbles were cracked, right? Or what else about the marbles? Anyone else know anything else about the marbles?
There's different colors.
True. If you really looked inside of them, what would you have seen? What? Yes. Or there were air bubbles in the marbles. Right? What would that do? What would that do to your volume? or the mass, I guess. This would cause the mass to what? The air bubbles. Yeah, to be less. Which would cause the density to what? So you say what would happen, and then how is it going to affect the calculation? If the mass is less, the density is going to be to also be less. You got it. To also be less. This could be improved by ideas.
Money.
What?
Money.
Money?
Buying better marbles.
No. Think more critically. How would you get the air out of the marbles? How'd you get the air out? There's only one way to do it. Crush the marbles, right? Crush the marbles into a powder and then take the volume of the powder. Agreed? That's what I would say. So you guys can write that on your own however you want to. That's one improvement. Another limitation of the lab was, did anybody notice anything about the graduated cylinder as you were putting the marbles in?
Like the water like splashed.
As marbles were placed in the graduate, some of the water splashed up on the sides of the cylinder. This caused volume to be what? Less. That would result in density being greater, higher. How can you improve that? This could be improved by what? Instead of just plopping them straight down in, what could you do to improve that? Tilt the cylinder and roll the, yeah, you got it. This could be improved by tilting a cylinder and, I don't know, gently rolling them in, all right? And gently rolling marbles in. So a good limitation section says, what's the limitation? What variable does it affect? How does that affect what you're trying to calculate? And how can you improve it? So that's 4 things. So that means that this limitation is probably worth, this limitation section is probably worth 8 points. That is what you have to do to finish the lab. So you'll finish your calculations, you'll show your 2 sample calcs, you'll make your graph, mass versus volume. I showed it a little bit here on mine, but I would prefer an R squared value. So R squared, do you guys know how to display an R squared? So if you go, when you're adding your graph and stuff, just hit display R squared, which it should be close to what? It should be close to 1, R squared, because that's showing that it's significant. Make sure you have titles, units on your Y, titles, units on your X, mass versus volume for your title, line, all that. This is due on Wednesday. Cool? Okay. So you guys have the last 5 minutes to ask me any questions you have.